Hey everybody, Thrift Store Hacker back again, and today I have made a portable volt-watt amp meter that you can hook into any DC device that's rated between 5 volts and 60 volts and pulls less than 100 amps. I actually have one of these on the electric trike, and it helps me do power management while I'm riding, kind of keep my charge a little bit longer. I can see exactly how many watts the machine's pulling. But I just put it in this really nice cardboard box that I had. As you can see, the wiring schematics right here. There's a model number and all that stuff right there, in case you want to punch it together. I think I got this for under $20 online. As you can see, there's a shunt there that it measures the resistance behind. I did a little video on this before I put it on the electric bike, but as you can see, I ran the shunt in really thick gauge wire, so I can actually run 100 amps through this system and not completely barbecue it. And then to put the wires together and make them go through the box here, you can see I just have a couple of washers. I use these large, they're kind of like fender washers. I use these large washers and a bolt. So we take 2 of the washers, put them on one side, and this will go inside the box. And this will allow you to put the wire in there, and when you tighten the bolt, it'll pinch down on it. And then on the outside of the box, you put this one, and this one's more for like stability. But when you have it on with the bolt on, it'll actually give a really good area to connect the any of the negative terminals that you need for whatever piece of equipment you're testing. And as I said, it only costs under $20 for this, and then you can put a switch on it, and then little bits of wire in a cardboard box, so it's a relatively cheap and simple project. Now we're going to take a look on the outside of the box. You can see I have battery negative to device, so this will go out. This will be the negative load for whatever piece of equipment we're testing. The negative battery in and to the positive on the battery, which we'll hook up right now. So here's our positive to the battery. Plug that in. And I'll have to do up a negative lead here. And this just hooks in line on the negative of any of the any DC device you want to test. The positive here is to run the display. So we'll hook this into the negative from device, and we can turn it on. You see we got 13 volts going. You can see this one's been used quite substantially with all the watt hours in it. Now what I have here is a kind of hokily built LED light that has 3 of these panels that have 50/50 SMDs on them. There's 12 per. I have that right here. So I'm going to be connecting this to the other side of the box here, which is the negative. And then I'll take this one and I'll connect it up to the positive. And you can see my light came on. If you look down at the gauge, you can see we're drawing 0.37 amps at 12 volt, well, at 13.06 volts, and it's pulling 4.8 watts. Now, that's kind of interesting. It's only 4 watts, so why don't we put something with a little bit more power on it? Well, that draws a little bit more power. So we'll disconnect this, set this aside. Now, if you watch some of the stuff on my channel, you'll notice I have the electric glove warmer here, which we turned from a portable car heater into a glove warmer where you stick a tube on the end of this and you can stick your gloves in it and it'll warm your gloves up and dry them out. So we'll plug this into the machine and try it out. It's got 2 settings where you can turn the heating element and the fan on or just the fan. So we'll try both settings. Once again, we plug the positive up to the positive over here. We'll plug our negative into the side here. There we go. Now we're going to turn this on fan. You can hear it power up. See if I can zoom down into this display, or at least get it so you can see it better. You can see we have 3.3 watts being drawn by the fan at half an amp. Now let's kick the heater on. Now, this is going to draw substantially more wattage. You can see it's already pulling the battery down. It's pulling 9 amps and climbing. It's going to build more resistance as the heating element gets hotter, so we're just going to let it pump up here. Let me zoom out a bit here. Let me see, we have this running. Let's see if I grab my temperature gun here. Got the temperature gun. It blows about just under 100 degrees when it's getting warmed up. Still climbing in temperature though. But it looks like our load here has leveled off. It's 10.82 amps. We're pulling 134 watts. And the thing with this is, like, if you have a solar power grid or something like that, and you just want to see either what's coming in or what's going out, or, you know, just whatever DC voltage, you just want to see what the power draw is on it. Like this right here, this little glove heater, or glove dryer. See if I can zoom out a little bit more. There we go. This little glove dryer right here, if you put it in a car and you were pulling 130, 140 watts off of it while the key was off, your battery would probably be dead in an hour. But now that I know that it only pulls 134 watts, maybe we can take it and put it up on a 100 or a 200 watt solar rig, and it would continuously provide that amount of heat. And then I could put it in a tent and do camping with it. And if it's really cold out but the sun's out, we can just run the heater continuously just off the solar power. Now, one thing I did notice is, since this is a kind of a cheap thing that I got online, it does have a problem when you shut it off and then go to turn it back on again. Sometimes it won't come back on. Now, if you have one of these particular devices and it won't come back on, and you know you're 100% sure you hooked this thing up the correct way the first time, I can almost guarantee you just shut it off, let it sit for about a half hour or 45 minutes, and I guess, let it drain all the power out of the capacitors and let it go dead cold, and then plug it back in. But always hook up your positive and negative power first to power the display and turn it on, and then add your load. And if you add your load after that, it should work perfectly fine. Once again, for 20 bucks, I'm not going to be too picky. A good one of these is probably upwards of $50, $60. You can pay all the way up into $100 for one. But this is going to serve the purpose that I need it to serve. It does what I need it to do. It'll show us all the voltages and whatnot. We'll kick that back on. See, just building up current again. But it's going to show us exactly how much voltage it pulls, and wattage and amperage. And that's just really handy to have, because if you know your amperage, you can do your speed controllers and stuff like that. Actually, let me grab a speed controller right now. Now, if we were going to run this, it's a 10 amp, so we would probably need like a 20 amp speed controller so we don't overheat it. This is the speed controller off the electric trike. Update coming soon. Some new stuff happening with that. But online, this says it's supposed to hold 3,000 watts. It's supposed to operate from 6 to 60 volts DC. I know for a fact if I ordered the 40 amp one, it would just burn out on me, even though I was drawing 30 amps on it. So this big old 60 amp setup has been working out pretty good for me. The only thing you have to worry about with this particular PWN, it is super cheap. I think I paid 18 bucks for it. But if it burns up, it doesn't burn up and shut off. It will burn up, and then it will make your bike or whatever device you have run at full power until you disconnect the power from it. So I highly recommend a voltage cutoff of some sort. You can get them at Harbor Freight, those big 50, 100 amp switches that they put on the back of drag race cars, so you can kill all the power to it if need be. But I would run some sort of circuit cutoff on it. That way, if your bike decides to burn out its control board and go full bore, you have A, a way to stop it, and B, a way to cut the power off before you crash. I was using a lower amperage version of this on the recumbent trike, and I was making a U-turn on the street, and lo and behold, the controller burnt out, so it went full speed, and I stuffed it right into a drainage ditch. So voltage cutoffs are probably a really good idea. You see that's still working pretty good. That's just a little tidbit I have for you today. I'm going to post something on Instructables about this, how you can build your own one. It is really simple. You don't really need a whole lot of electrical know-how to put this together, and it's really handy to have. But until next time, build stuff and have fun. And if you like my channel, please subscribe.